Hello, welcome. This is now question 2 for January 2003 Edexcel M1 paper. Now this particular question is all to do with resolving forces. So if you've done AS Physics, this is the topic of equilibrium. Also, if you've done AS for the Maths Mechanics 1, this is also called equilibrium. This is exactly, again, the kind of question. This could easily be in an AS Physics exam. So there's nothing really, I mean the only difference between M1 and AS Physics is the difference in the vectors and hill climbs. But anyway, just random talk. This question that I'm going to be doing. So we're told the particle, they just call it a particle instead of a person, you know, because apparently torturing people is a bit off the chart these days. So anyway, we imagine this person, you know, a person you don't like. Unfortunately, can't do that. Can't be me, you know, because I'm kind of explaining this question, and I wouldn't be able to do that, I don't think. Anyway, so this person at O, we've got these forces being pulled. They're being pulled in different directions, but we're told it's an equilibrium. So it's at O, and it's being pulled. So the angle from C to B. So the angle, because where it is at O. So you can just look on the paper if I'm not explaining it brilliantly. We'll call this angle theta. So it's O. The angle COB. So basically, what that means is you start at C, it turns at O, and the line ends at B. That's essentially what it means when it says the angle COB. Anyway, it draws the angle on, so you should have no problem with that. Okay, so we're told it's an equilibrium. Okay, so the first thing I would do, well, it's obviously asking you to find out theta, sorry. The first thing I would do in this question is think, right, well, it's an equilibrium. Now, this force can obviously be resolved going horizontally, otherwise this C point would just be pulling the object consistently all the way to the right. If there was no sort of part of this B line here, this 12 Newton, so this 12 newtons has to be resolved in terms of going horizontally and vertically, because there's a force pulling it down of 8 newtons, and if there's no component of a force pulling it up, then surely it'd just be going down. And if there's no horizontal component of B, then C would just be pulling it all the way to the right. So I'm going to start with the opposite of A. So for it to be an equilibrium, it's got to have the same forces. So we're going to resolve it into horizontal and vertical planes. A plane is just a direction, so it's horizontal or vertical. So horizontal, so therefore it's being pulled down by 8 newtons, so it has to be pulled up by 8 newtons to stop it going down. So 8 newtons. Now, we've got a bit of a problem here, because we want to work out what this theta is. Okay, so I'm just going to draw a line backwards from C actually. That's going to be x newtons. Right, so what we can deduce from this? Well, the angle theta is obviously bigger than 90 degrees. And when we do the line up from A, the principle is that this will always also be 90 degrees, because we've just done the angle twice here. Okay, so what I would draw on, I've gone past this box so many times, it should be in a high place. So this angle here is also 90 degrees. I've drawn it quite big, because if I draw it smaller I'd probably end up messing it up. So we can assume that's 90 degrees. Now this is a principle I do it, because I feel doing it this way is a lot easier than the way it shows you in the exam. And you'd still get the marks for it, because you get the same answer. It's just there are many different ways of working it out. So this angle that I'm going to call, so this one here, that there. So I'm going to call this the angle Z, because I can. So say this, because we've got A down here, and I'm going to call this negative A at the top. Okay, so the force pulling it up is negative A, because it's the same as A but in the opposite direction, so it's negative A. Okay, so this angle, negative AOB, so remember, starts at negative A, turns at O, and ends at B. So basically, this Z angle, okay, we want to work out what this Z angle is. Now, obviously, we know it's got this negative A is 8 newtons because it's been pulled up by 8 newtons. It's been pulled down as if it was being just pulled down by 8 newtons and nothing was supporting it. Then it just go straight down. So I just move a little bit out of the way so you can see that. Okay, so now you can see there's 8 newtons pulling it up. What we have there is obviously the Z angle. Sorry, repeating myself twice. I was kind of looking for something. Sorry. Okay. So if you turn the paper on its side, and I can't quite do that with the whiteboard, but if you turn the paper on its side, or look at it, you know, just be a weirdo in the exam and tilt your head. What we've got there is that Z angle has got a hypotenuse. If you were to draw that as a right angle triangle, it's got a hypotenuse of 12 newtons and a adjacent of 8 newtons. Okay, so therefore we have to work out what this cos as Z is. Now the way I think of it, I don't generally think of it as in terms of SOHCAHTOA, so what I do, but I don't go through with it as 12 over 8 or whatever equals Z, cos of Z. I just go, okay, well, you could do it either way, but we're going to use cos, obviously. So 12 newtons times the cos of Z equals 8 newtons. That's how I start this question. Sorry, just check on something now. So what we're saying is 12 times the cos of Z is equal to 8 newtons. Oh, I'm just for 8, because when we cos inverse it, we're not going to be bothered about the newtons being there, really. So the cos of Z is 8 over 12, not 12 over 8, sorry, I'm just a bit of a mess there. So therefore Z is equal to the cos inverse of 8 over 12, which is 3 over 4. Doesn't matter which one you put in your calculator. So therefore you get an angle of Z to be, so just double check, 48.18 newtons, sorry, not newtons, 48.18 degrees, 89 degrees. Now, how does this enable us to work out what theta is? Well, now we know that the angle made between the line going up 8 newtons, so negative A, so the angle, so because we said that was, so the angle negative A, OC, so this angle, the red one I've drawn, we know that's 90 degrees, and we know what our Z angle is now because we use trigonometry to work it out, 48.189 degrees. Therefore we say, okay, well, theta, because these two angles perfectly make up theta. So theta is equal to the Z angle plus the angle negative AOC, or what I call 90 degrees. Oh, right angle. I should have said right, you know. Well, that's what people, not just me, obviously just me says that. No one else calls it a right angle in the world. That's Jeremy Clarkson there. Oh, fancy myself. But I'm going to take the new Top Gear job, actually. I'm the new person. Anyway, waffling on. So what we're saying is Z angle plus 90 degrees equals theta. So it's just 48.189 degrees plus 90 gets you the angle for theta, which is 138.189 degrees. Now, it asks you to put it in to one decimal place, so it's just 138.2 degrees. That is theta. Now, that is the correct answer, but as I said, I think the mark scheme does it a little bit differently. Oh no, it doesn't. Yeah, the mark scheme does exactly pretty much what I said, but it's, I think the way I've done it there is a lot more easier to understand than what the mark scheme gives you. Okay, so all you need to, as you could have done it from this negative x, we'll call this, negative c point, and worked out what this angle is here, although you probably would have had to end up doing what we did here, and it would have been just a pointless addition to this method that we've done, because we don't know what x Newton is. And weirdly enough, we're probably going to end up finding it out at some stage. Oh, look at what this question says. The value to 2 decimal places of x. Okay, so it's nowhere near as complicated, this next bit, as what we've just done. Alright, okay, so Obviously, you know, lines on a straight line add to 180, basic year 9 stuff. Right, so what we've got here is Z plus this 90 degrees we know was 138.2 newtons. So therefore this angle here, this angle negative COB, so this angle here, we know that's 180 degrees take away 138.2. Okay, so if we work out what that is, which is 41.8 degrees, to 2 decimal, but personally I wouldn't use, I've just gone that off straight in my head because that's 138.2. I'd use a proper angle that you should have worked out, which was 138.189, so that would be 41.111. So that would be the angle we use, or just 48.189 plus 90. Should have just said that because I'd probably get it wrong there. So anyway, that's 180 take away what theta is. That'll get you the angle for negative COB. So remember, it starts negative C, turns at O and ends at B. So therefore we get that angle. Now it's just trigonometry, so a similar thing to what we did here. So 12 newtons times the cos of theta, which is 41.8 degrees, or whatever you got by doing it specifically, and that's equal to x. So therefore you just get, it's a lot simpler, so it's just you get a value for x, which is 8.9 newtons. Okay, so that's question 1 for January 2003. It's quite a nice question. Oh sorry, it's question 2. Why was I saying question 1? I have no idea. Sorry about being saying question 1. The title does say question 2, so you probably think I've gone insane. Just what happens when you do maths, say. So anyway, that's how you'd work it out. As I say at the end of every single video that I do, please do let me know so you can switch off now if you're bored. Please do let me know if there's anything you want me to go over, or try and explain it in a different way, and I will do. So thanks for watching, and we'll see you in the next video.